My name is Steve Chizmar, Bureau Director for PennDOT's Bureau of Innovations. It is my pleasure to host a series of podcasts celebrating the 10th anniversary of Pennsylvania State Transportation Innovation Council, or STIC for short. The second installment of the STIC's 10th anniversary podcast series focuses on successful STIC and Federal Highway Administration Everyday Counts innovations from the past decade. Today, I am speaking with Kristen Langer, Assistant Chief Bridge Engineer in PennDOT's Bridge Office, and Randy Albert, Municipal Services Supervisor in PennDOT District 2 in Clearfield County. Kris and Randy were instrumental in bringing geosynthetic reinforced soil integrated bridge systems, or GRS-IBS for short, to Pennsylvania. GRS-IBS is an accelerated bridge construction method that was championed by Pennsylvania during rounds 1 and 3 of the Federal Highway Administration's Everyday Counts program. Welcome, Kris and Randy.
Thank you.
Thank you. Pleasure to be here.
Okay, folks. So I'll tell you, Kris, why don't you go first? Can you please tell the listeners a little bit about yourself and your involvement in the development of, and I'm going to have a mouthful here, the geosynthetic reinforced soil integrated bridge systems, or we're just going to say GRS-IBS from this point forward. So, Kris, if you can tell the folks a little bit about yourself. Thanks.
Well, as you said, I'm one of the Assistant Chief Bridge Engineers here for PennDOT. I'm the central office subject matter expert for ABC, or Accelerated Bridge Construction Technologies, of which GRS-IBS is one of them. I was introduced to the GRS-IBS through the municipal services and specifically through Randy when we looked at trying to get it into our publications so that municipalities could use their state funding to build more GRS-IBS bridges.
Thank you, Kris. Randy, same question to you. If you can tell the listeners a little bit about yourself and your involvement with GRS-IBS.
Sure. As you said, I'm Municipal Services Supervisor in PennDOT Engineering District 2. We oversee and assist local governments in 9 counties in north central Pennsylvania, and mainly we help them with funding, seeking solutions to highway and bridge problems. GRS Bridge Technology has been one of my most satisfying achievements in my career at PennDOT. I've been involved since the beginning of GRS in Pennsylvania and throughout the whole evolution of the process, starting with the first bridge in Houston Township in Clearfield County, and then promoting the process with FHWA, development of the specification, and most recently securing and participating in updating the specification with some funding from FHWA.
Oh, well, thank you, Randy. Randy, actually, let's take that a little further. What was the original vision for GRS-IBS, and why did you advocate so strongly for its use in Pennsylvania?
GRS-IBS started out more of a solution to a local problem than a vision. There wasn't any influx of funding or big grants to get it started. There wasn't a big study group or research group in Pennsylvania implementing a pilot project or anything like that. It just started to be promoted by FHWA in their Everyday Counts program, but originally it started as a solution to a local bridge problem in Houston Township, right here in central Pennsylvania. I'd seen a presentation by Bob Barrett. Bob was a pioneer in GRS-IBS technology, along with Mike Adams from FHWA. And part of my job at PennDOT, as in assisting local governments, is finding solutions for road and bridge problems. The idea sat in the back of my mind until 2011, when a small bridge in Houston Township was closed due to the deterioration that had occurred over the years. I mentioned GRS-IBS idea to them and advised them it was purely experimental and that they couldn't utilize any of their state funds or grant money at that point. We discussed the things that FHWA promoted: ease of construction, the economy in building it, the quick turnaround time, and getting the bridge open. And since they wanted the bridge open as quickly as possible, they decided to move forward. They got their engineer involved. We got in contact with Mike Adams from FHWA, as well as a gentleman named Warren Schlatter from Defiance County, Ohio. Warren had built the first large-scale GRS-IBS and was also involved in much of the testing and development of the process. From those conversations, Houston Township moved forward and built the little bridge that made a pretty big impact in Pennsylvania. Many people recognized the success of that project. It was built by local forces. It was very economical. It was done very quickly, and it received a lot of coverage, including many news articles, an award for local government innovation from the Pennsylvania Township Association, and it became one of the main focus projects of SHWA, promoting the project nationally. From there, a special specification was developed with Kris, as she mentioned, getting involved at that point. She was involved heavily in refining and perfecting that. And the process gained traction locally with other municipalities building bridges across the state. A few of those also received awards and recognition from different entities for the success of it. Specifically, they recognize the cost savings, the ease of construction, the speed of construction, and of course, everybody mentions the elimination of the bump at the end of the bridge if constructed properly. So that's kind of how it started. It really wasn't a big vision or anything. It just started out to be a solution to a problem and then took on a life of its own.
Thank you, Randy. And really, it kind of gets to the heart of what the STIC is all about: finding solutions to problems and implementing them here in Pennsylvania. Kris, with that in mind, can you tell us what were some of the largest hurdles faced in developing this technique for usage here in Pennsylvania? And how did you overcome those and basically get PennDOT districts to buy in and embrace this technique?
It was definitely a paradigm shift for the districts. We up till that point, we had been pushing for a 100-year bridge life and trying to get longer life out of our bridges. And now all of a sudden we're coming in with this brand new technology that doesn't require the skilled labors of, master craftsmen to build a structure like that, and it can be built with local forces, and trying to convince them that this structure was worthwhile and useful when we really didn't know the life of that bridge, and the estimates were only for 30 to 40 years as opposed to the 100-year life that we kept pushing. It was really a shift to try and get the district bridge engineers and a lot of our consultants on board to use this newer technology. We overcame it basically the way you do most anything, is by taking baby steps. We had to acknowledge their concerns while noting that this wasn't a perfect fit for every situation, but that it was, to use the catchphrase, a tool in the toolbox. The big hurdles that we use, or obstacles that we found and how we overcame them, was getting the public information out. We had a lot of showcases where we brought in engineers and municipalities and contractors to show them what the GRS bridge was, how it went together, how smoothly it worked. We even had them at some of the bridge sites as we were building the bridges to show them what was done and how it worked. So we encouraged the locals to use it because they had the personnel to do the work. And our first hurdle was to get it into Pub 447, which is for the low volume roads. It was that way we could use liquid fuel funds to fund building those type of structures in the and it encouraged the municipalities to try this new technology, because that way they could use their own personnel to build a structure of that type. Once we started with that, then we created the standard drawings that gave the designers the implements to design that type of structure, and we pulled in the spread, and we gave them access to the spreadsheets that FHWA had developed to design the GRS-IBS structures. So that made it easier for the designers then to start using them. We also put it into our bridge maintenance manuals so that we could get district maintenance forces using it. So we just did a slow progression as to getting it into the publications and giving them access for people to use it. And as the districts were able to see the benefits and the ease of construction, we were able to encourage each district to try a GRS bridge. Most of the districts within Pennsylvania have at least one GRS bridge. The biggest challenge for them is finding a bridge with the right criteria and meeting the right site requirements to build one. But the technology has been well received within Pennsylvania.
Well, Kris, let me ask you kind of a next question. I heard you mention municipalities several times in your last answer. Can you tell us more about the benefits of GRS-IBS, especially as to how it relates to the use by local municipalities?
Well, as I said, they can use untrained maintenance forces. Their township personnel, or the borough street department can build these structures. I mean, it doesn't take a huge technical background to build something of this type. The components, the concrete blocks and geotextiles are relatively economical and readily available. And they can be used with many different types of structure types, superstructure types. They can be used with concrete beams or timber structures, as our first GRS bridge was done because they had a timber manufacturing plant close by that was able to give them the superstructure. It can be more cost effective to build these structures when your own maintenance forces are being used as opposed to hiring a contractor.
Oh, thank you, Kris. Randy, kind of switching gears here for a second. GRS-IBS received FHWA STIC incentive program funding, I believe, in 2017 and 2018. Do you recall what that funding was used for, and how did it help in moving the innovation forward?
Yeah, the original specification was purposely highly restricted to be able to monitor the process closely and give the engineering community time to realize it was indeed a viable solution for replacing bridges. In 2018, an opportunity opened up to apply for FHWA funding through the STIC incentive program, and it was proposed to utilize the funding to explore expanding the specification. In 2018, half the funding was provided, with the additional half in 2019, as you mentioned. We contracted with Penn State. They did an extensive national research effort and evaluated all the information that came in that they could gather, and based their recommendations to update the Pennsylvania specification after all that research. Penn State actually recommended lifting most, if not all, of the restrictions in the PennDOT specification. The FHWA guidelines in many other states are not quite as restrictive with the technology as what we started out as. In our efforts to be sure the technology remains safe and viable, PennDOT limits the locations where it can be implemented. And keeping the same cautious approach and recommendations of PSU, we're back down or pared back a little bit to an acceptable level so we could take the next step, but not open the specification up completely to everywhere to where it could be used. So we're taking another step, and it's a good step in the right direction, but it's also remaining cautious and making sure we're safe with the bridges that we're putting in. The specification updates include increasing the ADT on the routes where it can be utilized. It improves the options for the facing elements, or the wall, if you want to call it that. And it expands the length of the structure where it can be placed. Just as an example, Federal Highway allows them to be placed up to 140-foot span. We were at 70 foot on our original specification, and this new specification update is taking us to 100 foot. And it also looks at some stream velocity situations. That's one of the big concerns with the bridge, and we've made a move towards a more durable, robust facing material in order to address some of those. All of these are still below what FHWA and Penn State recommended, but they're the next logical step for us to create a better specification. These updates, they're in the final stages to expand the locations where the technology can be utilized, but still keeping a watchful eye on the technology as we move forward with it.
We're going to switch gears here. Kris, the STIC's motto is innovation through collaboration. How do you feel the collaboration helped in advancing GRS-IBS in Pennsylvania?
Well, really, we were one of the front runners in implementing GRS-IBS on a statewide level. We really helped other states advance GRS-IBS nationwide. So we really were collaborating with others to try and advance it there. I was asked by FHWA to present at the EDC forums around the country to explain how PA implemented GRS-IBS. We explained, answered questions, and helped other states bring in GRS-IBS to their state's design criteria. Through helping others implement GRS, we've started looking at ways to modify our own GRS-IBS standards. All that being said, we did get a lot of help and collaboration in developing our standards and our program from the experts at FHWA. Randy already mentioned Mike Adams, also Jennifer Nix and Dan Alzamora were crucial in helping us to fine tune the details and get our standards to where they would be easily constructed and easily used throughout the bridge community. We're also, and as we talked about, we're modifying our details and based on our experiences now in collaboration. Um, we're modifying our details from our experiences as well, learning from issues we've had. Recently, we had a GRS-IBS bridge damaged during some construction near the bridge. Randy and I collaborated with the municipality, our utilities unit, and some contractors so that now we've improved our product by adding underground marking tape to delineate where the bridges are, similar to the tape used by utilities. And I think that's going to help us keep our bridges lasting longer and better coordinating between construction that happens in the vicinity to keep our bridges safe.
Oh, thank you, Kris. Randy, GRS-IBS was originally introduced by the Federal Highway Administration's Everyday Counts program in 2011. How has the innovation evolved over the years, and what does it look like now? I know you've answered a good bit of this already, but if you can just expand on that a little more.
Yes, I'm more than happy to. Evolution of GRS-IBS in Pennsylvania has been both exciting and frustrating. Certainly wouldn't have happened without FHWA, just to mention a couple other names, Karen Vandervoort and Renee Siegel, also instrumental in promoting the process and, having an open mind to the process and willing to go with it. We've seen the technology grow from an idea to solve a local problem into a fully developed and implemented process. It's been very fulfilling to see that happen, to see it have its humble beginnings as a local project with many supporters, but also many critics. There's still a number of people out there who don't believe in the process or its potential. It's been interesting to see how it adapts to all type of superstructures. Kris outlined all of those. And that's the key to much of the economy of the system for local governments, is to be able to adapt and build them themselves and put the type of superstructure in that is most economical and most effective for them. Contractors have also built them with varying degrees of success. And when they realize the process isn't a typical contracting process, they're more successful with it. GRS-IBS abutments is actually more of a retaining wall type of construction. And we saw that recently in a project with DCNR. They had a landscaping company with retaining wall experience build the abutments, and they're probably one of the 5 best GRS projects in Pennsylvania to date. At this point, we have approximately 36 structures in the state at this time. When you think about it that way, we're averaging 3 to 4 structures per year. That's quite impressive for an emerging process with a very limited window of locations where it could be implemented. Hopefully the expansion of the specification will allow it to continue and develop and grow into the next level where it needs to go. Many people ask me my thoughts on how and where it should be used. I think the potential is limitless. I see numerous locations where it could be utilized if someone would take up the banner and promote the technology. It's been extensively tested and implemented around the country and internationally. We're taking a much more conservative approach, and rightfully so, but I think there's much more room where the technology could benefit the transportation network. We haven't remotely tapped the bridge opportunities, let alone the potential in retaining walls and above and below the roadways. But overall, it's been a very successful implementation and evolution of the process.
Thank you, Randy. Kris, what's the future look like for GRS-IBS here in the Commonwealth?
As we mentioned, STIC funding has helped us expand the idea of GRS-IBS and where it's applicable. We've been working since 2018 to increase those locations and update our standards as to where GRS-IBS can be used. I think that implementation is going to be coming very soon. We need to also start evaluating whether GRS might be viable for use as an overpass structures and retaining walls, as Randy mentioned. Many states already use GRS for overpass structures, and I think that's an avenue that we may need to start looking at. We've already started using the GRS, the geosynthetic reinforced soil, as part of our resiliency program, and we're starting to look at using that retaining system behind other structures where flooding and resiliency issues could be a problem. trying to make our structures last longer, not just using the GRS-IBS, but just for all of our bridge structures, because we've found and we've seen where the GRS-IBS perform very well. Some of our bridges we've seen uh, the GRS-IBS bridges seeing 15 feet per second on stream velocities, which is pretty high, and they have no impact, it's not had any negative impact on it. So we're starting to see to be able to tout the benefits of it and tout the resiliency of those structures and possibly be able to carry that forward into the future to increase our resiliency on our bridges, especially in flooding situations.
Thank you, Kris. Randy, the next question is for you. Do you have any advice or tips for how to get innovations moving forward in Pennsylvania and how to get the buy-in and support necessary to pilot those innovations on Pennsylvania roads?
As far as advice, I would say people have to be very, very persistent when they're working on a new innovation. Um, Many roadblocks are going to occur, and it's easy to get frustrated and be disappointed. I just recommend people don't lose your passion or desire to see it succeed, and have the courage to follow it through. I've seen this process and other process and products get bogged down in the development process. It's good to have many people involved, but sometimes that also slows things up and, results in maybe a cost increase or making it not able to be constructed, things like that. So we have to be careful with our process to be sure the restrictions are identified and don't get in the way of developing the process. I mean, they're certainly there to improve the process, but also we can prevent the process from moving forward. It's also imperative to keep the main focus, as they say. It's easy for groups with multiple input sources to get into the weeds and lose the original intent. So we have to be realistic and realize that, we have to stay focused on the original intent of the process. We also have to realize that every product or process is not the complete answer to everything. GRS-IBS bridges are certainly not the solution for every bridge. They're a very effective tool, and in many instances, a good solution, but they also have their limitations, and we can't force them into every situation. And finally, just keep an open mind and be willing to accept some changes and refinements in the process to advance the product. As long as the intent remains consistent and the changes don't result in it being not constructible or exponentially costly, then go with the changes and, get a better product out of it at the end.
Well, thank you, Randy. Last question to both of you folks. Is there anything that I'm missing or anything that either one of you would like to add?
Well, the advice and under the advice and tips, I say you also need to have a strong champion, somebody like Randy who's pushing the initiative forward. You've got to have somebody who's enthusiastic and who sees the benefits of it and isn't willing to give up without pushing for what they know is going to be a good solution for the needs of the Commonwealth. Randy was Randy didn't give up at all during the initial stages of this, and he was a strong proponent. So having a strong advocate is key to getting the new technologies moving forward. Um, GRS-IBS, like Randy said, it's not a magic cure-all, but it does have its uses. Considering their smaller span lengths for use, they can be a good alternative to box culverts as far as maintaining stream integrity and aquatic habitats, where we're now we're trying to make sure that we're keeping the stream environments healthy and strong, and that we're not affecting the fish life and whatnot. So the GRS may become a viable alternative to our box culverts in those situations where we have high quality streams.
Thank
Yeah,
you, Kris. Randy, anything else?
just to segue off of that, hopefully within the next year or so, you'll see some projects or a project or two that come through with some of that aquatic habitat aspect to it. And hopefully we can demonstrate that this product can actually fit into that. And, I'll echo what Kris had said. Without other people, behind the product, the folks from FHWA, support from Kris in, her involvement and her common sense approach to things, you can't do everything or anything hardly by yourself in this system. So you have to have support. You have to have help from other people. And it's good when you have a good product, a good process, and it just makes it that much better when you have people that join with you and make something happen. It's been a fun experience, and I hope it continues.
Well, thank you, Randy. I can think of no better way to summarize the entire interview today than your last few words there. So thank you. Thank you for joining us today and for helping us celebrate the PA STIC's 10th anniversary and its efforts to develop and deploy innovations across Pennsylvania. Visit www.penndot.pa.gov/STIC to learn more about the PA STIC and how we are innovating transportation in Pennsylvania.